Hello, Math 151. If f of x equal absolute value of x, what is the derivative? Well, what do we know? We know that the derivative or f prime of x by definition is limit as h is approaching 0, absolute value of x plus h minus absolute value of x all over h. And if I multiply the top and bottom of this fraction by the conjugate of the numerator, absolute value of x plus h plus absolute value of x all over absolute value of x plus h plus absolute value of x. Then I'm going to have this equals limit as h is approaching 0. Absolute value of x plus h to the second power. The middle terms cancels out, so minus absolute value of x to the second power all over h times absolute value of x plus h plus absolute value of x. And so what I can do now, I can simplify the numerator. So this is limit as h is approaching 0. What is the absolute value of x plus h to the second power? This simply is x plus h to the second power minus x to the second power over h times absolute value of x plus h plus absolute value of x. I'm going to go ahead and expand the numerator. Next page. So let me get to the next page. And so now I have limit as h is approaching 0, x to the second plus 2hx plus h to the second minus x to the second all over h times absolute value of x plus h plus absolute value of x. And so then I have limit as h is approaching 0. I can go ahead and cancel this with this. And I'm going to go ahead and factor an h from the numerator. So I have h times 2x plus h all over h times absolute value of x plus h plus absolute value of x. So what I'm going to do at this point, I'm going to go ahead and cancel the h from here and here. And when when limit goes as h goes to 0, then this h goes to 0 in here, and this h goes to 0. And so what I'm left with is 2x over absolute value of x plus another absolute value of x, which is 2x over 2 times absolute value of x, which is the same as x over absolute value of x. By canceling the 2's, now you know that this is the same as absolute value of x over x, like some textbooks show. Now, here we can hear you clearly, and I think that's the reason that some textbooks prefer to show that as absolute value of x over x, is for you to remember that x cannot be 0. And from the graph of f of x equals absolute value of x, we see the sharp bend at x equals 0, and we know that the derivative cannot exist. So let me go ahead and just actually show you that. So we said that, so far we said that if f of x equals absolute value of x, then f prime of x equals x over absolute value of x, which is the same as absolute value of x over x. And we said that x cannot be 0. So let's look at the graph of absolute value of x, which is something like this. And as you can see, the left-hand side limit and the right-hand side limit cannot agree at x equals 0. So as we are approaching 0 from left and from right, from left, the slopes are negative. No matter how close to 0 you get. From the right-hand side, the slopes are positive, no matter how close to 0 you get. And so because the limit doesn't exist, therefore, absolute value of x at 0 is not differentiable. Having said all this, here's what I invite you to look at this. I invite you to just look at a piecewise function for f prime of x. So for f prime of x or graph of x prime of x, so let's say that if this is my x and this is my y, so let's say this is 1 and there's a hole in here and there's a negative 1 and there's a hole in here. So notice that the graph for, so this was negative 1 and this is positive 1. So the slopes are negative 1 anywhere below, before x equals 0. That is from negative infinity to 0. So the slopes are, or slope is, or are negative 1. And what happens to the right? To the right, from 0 to infinity, the slopes are positive. Slopes are positive 1. No matter what part after 0 you look, it does have what point it has a slope of positive 1. So let's do a couple of examples. Suppose you have something like f of x equal, let's say, 2x plus 8. So what is the very first thing that you know about this function? You know that this is the mother function, or the parent function for this function is the absolute value of x. It's just that been shifted to the left and it's been stretched, up. So there are two ways to look at this. The way I like to teach you is to find where is the vertex, and I'll show you both ways. Would you agree that this is the same as saying f of x equals 2 times x plus 4? I didn't change anything. Hopefully you'll say yes. And this is the same as f of x equals absolute value of 2 times absolute value of x plus 4. And this is the same as saying f of x equals 2 times absolute value of 2 is 2, absolute value of x plus 4. And then I'm going to put a plus 0 in here just for the sake of discussion. And from here, you know that the vertex is happening as -4 coming from the opposite of this number from here. We covered this in Math 141, 0 from here. So that's one way of finding your vertex. The other way is, let me just simply say, if I have 2x plus 8 equals 0, my y-intercept is 0, then 2x equals -8 and x equals -4. So, at negative, you have a point now here at -4, 0. It doesn't matter to me which way you do it, so long as you understand what you are doing. So first of all, let's show this pretty much. So if I go 1, 2, 3, -4, 0 that we talked about. And remember that our function was f of x equals absolute value of 2x plus 8. Okay, and notice that this is, if I set that, we set that equals 0, we find out -4. And if you wanted to graph this the way it is, without the absolute values, you would know when x is 0, your y value is +8. So you're somewhere here at 0, 8. So this graph is going to look something like this. And so what can you say here? We can say that from -infinity to -4, slope is or r. The slope is -2 at any given point, and from -4 to infinity, the slope is +2. And some of you probably will argue that, I knew that. I just from the very get-go, I just looked at this and I guessed what the slope is. And, you're going to have to show your work. So I do encourage you to get used to showing your steps. And we said that at this point, at -4, at -4, 0, d dx does not exist. Let's do one more example. Suppose I have f of x, let's say this time something with 3. How about 3x minus 9? Okay. Same thing as, this is the same as f of x equals absolute value of 3 times x minus 3, which is the same as f of x equals absolute value of 3 times absolute value of x minus 3. So f of x equals absolute value of 3 is 3 times absolute value of x minus 3. And if I put a +0 here, so what's my vertex? My vertex is +3 from here, 0. Okay, and so let me go ahead and go to the next page. The graph is going to look like something like this. 1, 2, 3. I'll just stretch it just a little bit. And 3x minus 9 has a y value of, let's say, 9 somewhere in here. So this is going to look like something like this. And this one was 0, 9. Okay. And so what conclusions can we make? We can say the slope is -3 in the interval -infinity to +3, and +3 in the interval uh, 3 to infinity. And once again, the d dx at 3 does not exist. D dx of absolute value of 3x minus 9 at x equals 3 does not exist. Okay, thanks.